Now, how we've been working with these principles to help the PVC sector in Europe. And this is a long-term change initiative that we've been pushing for change in the sector for quite a long time, starting from a study with the UK Environment Agency that was published in the year 2000, which was basically trying to build consensus with, between Greenpeace on one side that was campaigning outside retail stores, and the retailers, and then the industry, to ask, okay, what's going to happen here? What should we do with this this material? If we need to, if it's the third most common plastic used in society, it's everywhere. We need to ask really what's the potential for it. So we asked the question: does PVC have a role in a sustainable society? And there's a big proviso to this, in that there's no technical reason why the PVC could not exist in a sustainable system, provided a certain set of challenges are overcome. So we identified 5 key critical challenges that we put out there and said these are things that the PVC industry needs to address. The good news, I could say, is that the industry's had voluntary commitments in place since the year 2000. Since the year 2010 or 2011, the second voluntary commitment has actually adopted those 5 challenges to form a 10-year roadmap. And again, I sort of point out that the benefit of having these principles was to bring people with sometimes skeptical views of sustainability, sometimes skeptical views of people outside the industry, and try to get them to look together at the science and come together around a common platform for taking collective responsibility as an industry and creating a roadmap. So VinylPlus now is a 10-year voluntary commitment that is actually engaging the whole of the PVC value chain in Europe. And you can see here from the resin manufacturers, the stabilizers, the plasticizers that go into the soft PVC, the converters that turn it into products, and then all the other companies that are out there making use of PVC products. Our role in supporting this is to try and advocate that the industry adopts a science-based approach to understand the sustainability challenges, that people are educated and know what they can do to work to address these challenges, and to also help the industry connect with stakeholders to bring in stakeholder feedback, and also then be more proactive in explaining to stakeholders what's happening, and also working with stakeholders to address some of the critical challenges. So the commitment today has 5 key challenges, addresses these 5 key challenges. And I can say that by 2020, not everything is going to be solved. We take a really long-term perspective of thinking, where does the industry need to get in the long term? And what's the roadmap to get there? So targets are set to 2020. There's 35 targets that are based around these five areas. There's a lot of detail here that is available online if anyone's interested to look into it more. What I think is perhaps interesting is this debate now that's coming up more and more in the context of circular economy, and especially the question about legacy additives. So when we look at the potential for PVC to align with sustainability criteria, it's obvious that it has to be in a controlled system. We can't just keep having it in a linear take, make, waste model. So we need to have a controlled loop system for it. So that's the fundamental thing, that we need that. At the same time, we know that it wasn't necessarily designed to go into a linear system. There are substances that are now restricted. In long life applications, those substances are going to keep coming out into the waste stream for the next perhaps 40 years. So we have a massive challenge in society to integrate waste from the linear economy into the circular economy. So the questions then about doing that in a safe and responsible way is not trivial. It's really important that we get this right. At the same time, we need to be designing new substances that fit into the circular economy from the outset. So it's two things that need to be done simultaneously. So here we have controlled loop management. Organic chlorines is about what happens if you incinerate it, of course, and the production. emissions that can come from VCM production and transportation. So controlling that, but then actually having a way to design the sustainable use of additives that aligns with those 4 system conditions. And that's an ongoing initiative within the industry now to actually develop a screening methodology that looks at the sustainable use of additives in different PVC applications to align with those 4 principles. So that's addressing that, but the question then is about designing a controlled loop system that can adapt or can handle the substances that we have coming into the waste stream. So that's, I think, an area for ongoing debate. What we can see, especially with rigid PVC, is that if it's bonded into the chemical matrix of PVC products, it isn't going to violate those sustainability principles. It's not systematically increasing in concentration. So the question then is about having controlled management of it in controlled intentional loops with clear traceability and under approved conditions that satisfy and build market trust. So that's one of the things that I think is really critical, and I know, for example, in the window profile sector, which is the largest PVC application in Europe, there is now a standard under development for the management of, or the controlled management of PVC in that application. There's certainly a lot more. I can direct you to the VinylPlus website where you can see lots about the progress of things that have been being done to really build up a recycling infrastructure, to have external monitoring, and to certainly really try and engage with stakeholders and understand what do people think. This is, of course, getting lots of recognition now in the discussion around circular economy about how to design a fully integrated system that takes care of the problems of the past, but also then builds for the future and designs a system that can have a material that could be recycled up to 7 times. So think 30 to 40 year applications, recycled 7 times. That's a couple of 100 years worth of material value that we can keep in the circular economy, provided we can do it safely. So I really recommend, if anyone's interested, to look at the website to learn more. And certainly I'm interested to hear from stakeholders that have got concerns or would like to learn more about it. Please come and talk to me. I'd be grateful for input. So just to conclude, what I'd like to just leave you with is the idea that you can both at what happens if we do allow them in recycled products, but also the alternatives, because the chemicals don't just disappear, they're just still somewhere, they need to be managed somehow. So the example I mentioned there with, I'll say on rigid PVC, where I can, we've been looking at window profiles, for example. If you just look at the alternative and say, okay, well, either we landfill it or we incinerate it, the consequences from a sustainability perspective are not so great. It's like it's a no-brainer that's a valuable material that we should be reusing. So then it's about the controlled loop system. And we don't have it today the way it should be. I can see things like approved secondary applications, transparency or traceability schemes. That actually does exist within the PVC value chain, that there is a traceability system connected to the recycling system that's being set up. Then I can see other things like thinking about the types of loops we want these in. Is it intentional loops? Is it controlled loops? Is it containment loops, where if we can, for example, with rigid PVC, the technology now is to embed the recycler within the virgin. So if you can imagine a water pipe that has got recycled PVC in the center that's encased by virgin that doesn't have legacy additives, there's an extra precaution that there's no migration of the legacy additives. So that is clearly the case on if the substances are bonded in the matrix. Where they're not bonded, that's, I think, a bit of a trickier question and needs to be looked more closely on a case by case, but I certainly wouldn't advocate putting unknowns into products like toys and whatnot. So I'm certainly on board with that.
Okay, thank you very much. We're approaching the end of this session. Thank you very much. I'm quite overwhelmed by information this morning, and it seems we still have a few challenges from the last discussion here. So that would not put us out of business in the next few years. But thank you very much. Should we give a final hand to the